chairman po ng Photoluminescent Lighting Council, which is Trevor Dimond.
Thanks for everyone attending. It's not easy getting together like this in a big city like Manila. The one thing I've learned is that you do allow a lot of time to get from place to place. I'm based in New Zealand, which is, explains my accent, but I will try and keep my talking quite slow, so hopefully we can get through this. Okay, so the Photoluminescent Lighting Council was formed in 2015. Represents the photoluminescent industry in Australia, New Zealand and Asia. We're associated with the European and UK associations, which is PSPA, and also the USA Photoluminescent Safety Association. Right. Ecoglo Fire Protection Product Trading, which is the Philippines entity, is sponsoring today's event, and so therefore I'll be using examples of the Ecoglo products to demonstrate some of the aspects that we're going to be talking about. The slides are set up with a lot of text on them, but the reason we've done that is that after the seminar we'll actually make a PDF of all the slides and send them out, and they should actually work as a manual, if you like. So most of the information should be in there. We're also setting up on Facebook a technical group, so that and you'll receive an invite by email, and in the technical group it'll be a closed group, but again questions can be asked, different technical aspects can be addressed without it being a totally public conversation. So first of all, we're going to look at some of the technical background of photoluminescence. We're going to look at the relevant international standards and how does each standard work. And then we're going to look at three clauses of fire code and how those standards can help compliance with those three clauses. Lastly, we'll be looking at quality assurance, making sure that the products that you want to use and have specified actually get installed. At some point we'll take a break in about 45 minutes just to stretch legs and have a comfort stop. At the end we'll be doing 10 or 15 minutes of formal questions in here, but then afterwards we'll be serving refreshments out in the lounge area out there, and there'll be plenty of time for more informal questions and discussion. Okay. The technical background. What is photoluminescence? So it's commonly known as an acronym as PLM, photoluminescent material, or just PL, photoluminescent. The material can absorb UV light and then re-emit it later as a visible light. It's, if you think of it like a storage device, like a battery, the energy from visible light is absorbed and stored in the photoluminescent material, and then when it's dark, that energy is used and emitted as visible light. Right, what type of light is suitable for charging PL products? Most commercial lighting will work. LEDs, fluorescent and metal halo. Incandescent is not so good, so if it's a really old building, There's incandescent lights, the charging for photoluminescent material isn't great. The key thing is that you look for the colour temperature of the bulb or the luminaire. It's printed on most packaging. A colour temperature greater than 4,000 degrees Kelvin is plenty of charge for photoluminescent material. Natural daylight is the most effective charge. And it doesn't need to be direct sunlight, just daylight reflected around the room will be enough to charge the material. First of all, let's just try and differentiate between illuminance and luminance. They're often confused. So illuminance is the amount of light falling on a surface. So we've got our light, which might be in the ceiling, and then it's how much light is actually being delivered to that surface. And lighting specifications, it's typically, for general lighting, it might be how much light is on a desktop in a office situation or an educational situation. Where we use it is how much light is being delivered to the photoluminescent material to charge it. It's measured in lux, and one lux is 1 lumen per square metre. So luminance is the amount of light being emitted from the surface. So this is the photoluminescent material, so it's the amount of light that it's then giving off. An example of that is the amount of light needed to be emitted from the surface of an exosign to make it visible. And we'll use this luminance measurement quite a bit in some of our references. Photoluminescent materials have a logarithmic decay curve, so they drop away like that. So if something's fully charged, it's up here somewhere, very bright, it's luminance, and over time it drops away. Now these lines here are established to act as minimums. That's the minimum in visibility. So although it's decaying or getting less bright through this period of time, it's still above that threshold for visibility. So here it's 800 odd millicandelas after 2 minutes, and then it drops away to about 30 millicandelas at 120 minutes, which is out here somewhere. So why the 30 millicandelas? That's the commonly accepted level of luminance for visibility of a sign. The 5 millicandelas is the commonly accepted threshold for visibility of a egress product, like on the edge of a step or on a handrail. It only needs to be 5 millicandelas. A sign needs to be 30. Why the difference? Because a sign, it's not just a matter of seeing, oh, it's over there. You need to be able to read whatever it's trying to communicate. Whereas the material on the steps and the handrails, you just need to see that it's there. So it's a lower threshold for visibility. What is photoluminescence? Well, it's not reflectance. It's not like you shine a light on a material and it immediately bounces back. When the light source stops, when that light stops, the reflectance stops. So the light on the photoluminescent panel is emitted from the light and it falls on the material. When the light source is on, no glow is really seen because it's only really contrasting with dark material. But the key thing is, when the light source stops, the light is still being emitted, then it's emitted from the photoluminescent panel. And then even a long time after that light has stopped, it continues to emit light from the photoluminescent panel terms of a sign or a stipulator, for instance. There's a manufacturing method referred to as high temperature curing. That's where products are cured in an oven at over 160 degrees Celsius. Why is that important to know? Because it really gives the products high durability and good reliance and dependability. So the durability in particular allows for outdoor installation. They also, these HTC products charge rapidly, and over a period of time, they don't shrink and delaminate as some other products do. Generally, you'd be looking for a 30-year warranty for products indoors, and outdoors, 15-year warranty. And frankly, the photoluminescent material lasts longer than 15 years outdoors. What doesn't last are whatever the graphics are that are printed on the side. So that's what limits the outdoor warranty. There are different ratings for materials used in different parts of the world. The PSPA, if you remember, is the UK and Europe Association. They have developed a grading of material that goes from A right out to G. So the highest luminance product or specification they have is class G. This part of the world, they tend to use it an S rating, so S5 through to S20, and S20 easily exceeds that PSPA class G. So this table is available if you're trying to use a PSPA rating, that will allow you to do it. Okay, what standards are we going to look at? First of all, NFPA 170. It lists most of the symbols needed for evacuation plans. It also defines the luminance or brightness of a photoluminescent material for an evacuation plan. ISO 7010 lists as a European standard or an ISO standard mainly used in Europe, and lists all the different symbols, signs, but also what we'll be using it for are the symbols on an evacuation plan. SATS 5367, it's published in the last few years by Standards Australia. That is used for hybrid LED exit signs. And I'll explain a bit more about what they are later. But it defines all of the performance for visibility. It also defines all the electrical safety aspects and also electromagnetic emission testing that's required. Again, an Australian Building Code specification, NCC specification 25, that defines the amount of light needed to charge a photoluminescent sign. It also defines the minimum luminance. Remember I said, we talked before that 30 millicandelas is the minimum luminance that a product or sign needs to be visible. It also defines the size of the sign required for different viewing distances. The larger a sign, the further away you can see it. ASTM E2072 and ASTM 2073 are often mentioned together, sometimes just as ASTM E2072 and 73. One is the test method that you use to test the products, and this E2072 defines the level of luminance again. And remember, this 5 millicandelas is that lower level that can be used for egress products, but not really for signs. Well, some signs, but not for exit signs. UL 1994, egress path marking systems. This is the standard used throughout the US for photoluminescent products in stairwells. In the USA, every building over 75 feet, about 6 or 7 stories, needs to have photoluminescent egress path marking installed in its emergency stairwells. It's supplementary to emergency lighting. So they have emergency lighting and egress path marking systems just for when if the emergency light doesn't work for some reason. Right, so that, what does the stairwell look like? This is just a run through. It's about a minute. And the typical egress path marking system is the edge of the steps, the handrails, it's the landing. It might also incorporate some directional signs, which are a lower level of luminance than the exit sign, because they're close proximity. You are in close proximity when you see them. You don't need to see them above the door from a long way away. Next stand is the PLC high luminance test, so it's one of the other functions that Photoluminescent Lighting Council carries out. It develops standards with its stakeholders where there's a gap in the market or in the regulatory structure. The PLC will try and develop and get some consensus on a standard to fill that gap. This high luminance test is the test that's used if you really want to replace emergency lighting with photoluminescent products. You can do that in some countries and some regulatory areas. I'll go into that a bit more soon. Remember I talked about the high temperature curing. There's also a test that tests whether the product meets the appropriate standards. So the products are then, by testing, they actually put them in an oven for 150 degrees for 20 minutes, take them out. Is there any shrinkage or delamination or distortion or reality? And the ASTM 155, this is really all about weathering effects. So it exposes products to temperature, to water, and to UV. So it's a common test used to determine whether a product can be used outdoors or not. Okay, so short quiz. Hope you remember everything I've just told you. No. Okay. So, it's exit signs around the world. You see them in many different forms, and this actually, the quiz will have relation to some stuff we'll leave later, but they often have different languages and they have a lot of information duplicated on the side. So I just want to see if we work out where these signs are from. So that's the first one. What country?
Vietnam.
Vietnam? Yeah. They're both Vietnam.
Yep. Spain.
Spain, yeah. That's Thailand, yep. Or UAE, yep. Malaysia. Yeah. So just keep that in mind, because you see, there goes a typical ISO sign, and then the local language is sort of put on there. It doesn't always work. In fact, in this sort of situation, it starts causing conflicts with what the code says. The code says that the product, that the sign should meet UL 924, which defines what the graphics are. So a UL 924 sign would only have that on it in the USA. But then they say, but it also must have an Arabic exit. So by definition, then it doesn't meet UL 924. Things get complicated there. Okay. How do these standards apply to the fire code? Just some principles of how we've approached this. So that these approaches have been developed over the last 5 years. Just interacting with stakeholders at trade exhibitions, just customers. We've also interacted a lot with the BFP to get their feedback and interact in terms of developing quite a I would say robust approach in terms of how we've put these together. What are we trying to do? Some of the code or some parts of the code is open to interpretation. So what we're trying to do is to make a decision, get some certainty, because there might be a number of interpretations, but the thing that you really don't want is variation of interpretations, because then the consultant interprets it this way, and the system's installed, and the regulator comes along with a different interpretation, and you've got a big problem. So our aim is to try and publicise and get these approaches out there, try and get everyone on the same page, as it were. And if the wording isn't specific, use an international standard to specify the performance levels. We've also used an ARC, which is commonly used, I'm not sure about the Philippines, but around the world it's used where, particularly in renovations, if there isn't an economic way to actually install a system that meets the current code, because this building is older, there is, the approach is called an ARC. It's near as reasonably practicable. I'll explain a bit more about how that's used. Okay. So the international standards can help in 3 ways. Define what a term or category actually means. It can determine or give you the material performance specifications. So that's really just how bright is the photoluminescent material, how fast does it charge, and how bright does it need to be. And there are also product specifications, which often still have the material performance in there, but also specify what does the product look like, what are its dimensions, and what are the text or graphics on the product. That material performance specification, we use that where the graphics vary between countries or regions. That's where in the quiz we had all those the different graphics. The material performance specification means that the sign or the material that say that the graphics are printed on still meets the luminance and visibility aspects. For instance, Australia uses only ISO Running Man now. New Zealand uses both, both. USA only has exit. The ISO Running Man is used for UL 1994, which is a lower level standard. Canada only uses the Running Man. What's the common thing under there is that the material performance specs are similar in all those regions. So, as I said, the three clauses that we're going to look at, evacuation plans, exit marking, to exit signs, and illumination of means of egress, which is emergency lighting. First of all, evacuation plans, we've all seen those before. So as I mentioned when we went through the standards, NFPA 170 defines what the individual symbols are on the evacuation plans, but it also defines the photoluminescent performance. So the brightness of the sign is defined in NFPA 170. They do it in two different ways. I think the exit sign over there meets those standards, and it's a pretty common specification for an evacuation plan. Some of the symbols defined in the Philippines Fire Code aren't in NFPA 170. So there we go to ISO 7010 to pull the ones that aren't in NFPA 170. And then there's even one that isn't in either of those standards. It's the emergency light, which we have said, okay, that's the flashlight system where you see in hotels and many places where they have a little flashlight sitting there to help you out in terms of an emergency. What are the materials that the evacuation plan needs to be on? As I said, the NFPA 170 defines the luminance, the background material for the evacuation plan. The fire code defines dimensions of each size. There are three different sizes, each one relevant to larger areas. What we found is that sometimes you get quite a large area and it's requiring a bigger size sign, but there are practical limitations to where can you put a sign that big. So the approach that we've taken is to say, okay, if you have like a floor area of say 150, 160 square metres, the code says you need one sign of that size. Actually, it may be more practical to use 3 or 4 smaller size signs distributed around that area. Exit marking or exit signs. Exit marking is the name of the clause. Okay, what are the standards that we're using here? Standards Australia's standard for hybrid LED exit signs, NCC specification 25, the ASTM, and also UL 1994. They are the 4 standards that we will be using here. So first of all, we just need to define what's an internally illuminated sign, what's an externally illuminated sign, and in a lot of areas, they try and define those two, but the code's too old to actually define what a photoluminescent sign is. So internally illuminated refers to a sign where the illumination source is inside the sign itself. On that chair over there, there's a hybrid sign. You can see that it has LEDs in it. So a battery backup sign, something like that, is an internally illuminated sign. The photoluminescent sign has the ability to store electromagnetic radiation. That's the definition from NFPA 101. But, so that's, I say, ability to store the energy that's embedded in light and then can re-emit it, release it in the form of visible light at a later date. An externally illuminated sign is where the illumination source is not within the sign. So it's, you know, on a wall, you'll see quite often there's a sign above a door, and then it'll have an emergency light on a different wall that's shining on that sign. That's an approach that's probably, I'd say, is going out of favour in terms of new buildings around the world for a number of reasons, which we'll come to in a moment. So we've got internally illuminated, externally illuminated, photoluminescent, and then there's this thing called a hybrid. It's a hybrid between an LED sign and a photoluminescent sign. So it's internally illuminated, but it's like a photoluminescent sign in that it doesn't have batteries, it has a photoluminescent panel that stores the energy. So exit signs, said, go into three different internally illuminated, photoluminescent and externally, and you've got this one here called a hybrid. It's a hybrid of those two. With the key thing to remember, the photoluminescent signs, they need an external light source. They need to get light from somewhere, but that light doesn't need to be there during an emergency. An externally illuminated sign, that light source needs to continue to go during an emergency. So it has to be an emergency light, it has to have batteries in it. Whereas this sort of approach, that light source doesn't need a backup battery or anything like that. That's what a hybrid LED sign looks like. One over you can have a look at later. And when they're installed, they look pretty much like any internally illuminated exit sign. Slightly different colour because of the photoluminescent material, but function in the same way. Okay, the clauses, clause A 1 to 5, basically says exits need to be marked and readily visible, the exit signs, and the access to the exit needs to be marked as well. So the exit to be marked by an internally illuminated exit sign, which could be a hybrid LED sign. The access to exit can be marked by any of those three: internally illuminated, photoluminescent, or externally illuminated. So the internally illuminated has its own backup source of light. Remember, the photoluminescent exit sign needs 54 lux. Remember the illuminance that we talked about before, for 60 minutes prior and during occupancy. So, if you got more than 54 lux, it does charge a lot quicker than 60 minutes. So you can engineer a solution around that, but that's the rule of thumb, or that's the bottom line that it needs to meet. And of course, the externally illuminated one, it needs an external lighting source that continues during electricity failures. So the material performance specifications, remember, determine everything except the graphics. So the material performance specifications for exit signs, you use SATS 5367 for a hybrid, and NCC specification 25 for a photoluminescent exit sign. So that determines that the material will have enough luminance to make it visible and for you to understand it in an emergency. Clause 6 is a little, A6 is a little hard to understand, but the definition that we've taken for it is what is commonly called low-level directional signs. And it's says they shall be luminous, photoluminescent, and meet suitable international standards. The directional signs are installed between 300 millimetres and 600 millimetres on a wall, so at floor proximity. The standard used is uses UL 1994. That's the one I remember I said is used in the USA for any building with more than 6 stories has to have a system like that. Okay, clause B1 to 3 talks about the illumination of signs. Suitable illumination is for photoluminescent exit signs 54 lux for 60 minutes, remember, prior and during occupancy. Externally illuminated signs, again 54 lux during occupancy and during failure of electricity. So the light for an externally illuminated sign needs to be an emergency light. Hybrid LED exit signs don't require any additional illumination. The LEDs are built in and it's been tested to show that illumination is sufficient. Again, the material performance standards, the same as before, SATS 5367 for hybrids and NCC specification 25 for photoluminescent exit signs. So clause C talks about the size of the signs. So we've set up, here's the, we know that we've got the material specification, how bright is the material. In clause C then determines what the, how big the signs are and what the text needs to look like. The key thing is the text needs to be 150 millimetres high. But then later, it also talks about in existing buildings, with externally illuminated signs, it can be 115 millimetres high. I haven't really seen many examples of that around. They always seem to be 150 millimetres minimum. So that's what they look like. So there's 150 millimetres high. Talks about the minimum height of the text. It talks about the word exit, and it talks about the stroke width of the letters. So taking all of the measurements from fire code, that's what you end up with. Now, you then use some international standards to say, okay, at this size, maximum viewing distance is 16 metres. And then, remember I said the larger the sign, the further the viewing distance. We've used the international standards again. Say, okay, if your text is 210 millimetres high, you get a 24 metre viewing distance out of that. Stroke width has also gone up a bit, so everything is in proportion to the 16 metre sign that's defined in the fire code. It doesn't specify the viewing distance in the fire code. That's come from international standards. Directional signs can be of either of those sizes, but obviously the exit is just moved over a bit and a chevron is put in there to indicate direction. Let's have a short break for a comfort stop and stretch your legs, maybe 5 minutes. When we come back, we'll be looking at emergency lighting. Okay? 5 minutes.
Excuse me. Meron daw po tayong question time after ng break.
Ayan, okay.
So, pwedeng pupayin niyo lang po yung mga questions niyo and then hit them. Thank you.
Pwede mo yun, baka makalimutan.
Yeah, that's one of, I also asked for that, the Microsoft and the Auto.
Sino yung ka-email namin si Ma'am Bella.
Si Ma'am Bella po, Antes, naka-maternity leave na sir.
Anong name ang wife niya?
Ano po, si Miss Yolanda Solis. Yes po.
Ilang kayo empleyado ng Ecoglo?
Around 6. Yes po. As of now.
Tagal ka na sa akin.
Ma'am, more than a year na rin naman po. Sorry sir, ano pangalan niyo po?
Engineer Robina.
Angel Rubina. Parang I heard of you na nga po kay Sir Keith. Nag-meet na po kayo before?
Sa Zoom lang.
Sa Zoom.
Sino kasama niyo nung nagpunta mo? Si... Sa office na na-invite kami sa office.
Nice. Okay po. Sige sir, lagyan niyo po dito.
Diyan na lang.
Opo, sige lang po. Opo. Ang camera lang naman po yun.
Yeah.
Kaya ako nung kaya na nagsip. Pero ako siya. Hindi ko na kaya.
So the last clause that we're looking at, the third clause of the fire code, is all about emergency lighting. And there's sort of a reason you leave it to last, because it is the most complicated. So, okay, so the standards that we're going to use to work in this area, UL 1994, TLC high luminance test, the high temperature curing test, the durability, again, and the ASTM, again, that's about durability in terms of standing up to weathering and the effect of UV. Egress path marking systems and emergency visibility that commonly interchange terms for the same thing. But what both of them are doing, making an emergency evacuation path or escape path visible and navigatable by people. Right, so the first thing it needs to know is that code says that no luminescent or fluorescent or reflective material can be permitted as a substitute. So you can't, if you're designing a new building, you can't use just photoluminescent products. You have to have emergency lighting as well. That's not the case in all countries. In both New Zealand and Australia for 10 or 15 years, photoluminescent systems have been allowed to replace emergency lighting, but not in the Philippines as of yet. Photoluminescent system can't be used as a total substitute, but where you're dealing with an existing building and you have systems that aren't up to the latest sort of regulations, I'm going to show you some ways that you can use a NARP and you can use photoluminescent systems to overcome some issues. So, as I said, both New Zealand and Australia have building codes. They no longer use the term emergency lighting. They either use emergency visibility or visibility and emergency, interchangeable. But they've taken out the term emergency lighting because you are allowed to use photoluminescent systems. Why are we looking at that? Well, you're saying, okay, if you are going to use photoluminescent systems to make your emergency lighting better or fill a gap or overcome some weakness, you need to have some definitions around it and some standards. So what we've done here is that we have made it a specification that would meet building code in both New Zealand and Australia for emergency lighting. So if there's a place emergency lighting in those countries, as I said, can't do that here, but if you've got some issues, here's a way to overcome them. So specified building details. They're stairs, ramps, safety features such as handrails, changes in direction and building elements that may act as obstructions. What does reasonably visible mean? It means visible from 10 metres away by an able-sighted person. So that's the definition is that sight is not defective or is corrected by an optical appliance, being eyeglasses or spectacles. Right, so you can't design a new building with photoluminescent material, but what you can do is saying there are 6 issues that are quite common with emergency lighting that you can use a photoluminescent system to overcome these specific problems. Outdoor emergency stairs, shadow effect, and battery generator reliability, changeover times, smoke suppression, and battery recharge times. So we're going to go through each of those and just show you how the photoluminescent system and how to overcome those problems. All of these solutions that we're going to talk about rely on the PLC high luminance test. So remember, what we're saying is that we're specifying a system that in other countries would replace emergency lighting because it needs to be a very high spec system. We're also going to use the high temperature curing test for durability. The system's going to see, like, why have some countries changed to allow systems like this? Because the body of evidence quite clearly shows that the photoluminescent systems can not only be the equivalent of emergency lighting, but in a lot of research, it's actually better, get better performance in terms of egress speeds of crowds evacuating a building. And if anyone's interested in that research, I can supply it. But take it from me, all of this is based on a lot of large body of research. Okay, first of all, first problem, outdoor stairs. So the code talks about means of egress is the exit access, and exit discharge. What's the exit discharge? It's the portion between the exit and a public way. They're just taken from the fire code definitions. So anywhere where you go through the exit door and you have some outdoor stairs, often it might only be 3 or 4 steps, but sometimes it can be quite a few flights of steps outside a building. That sort of situation is hard to light with emergency lighting because of maintenance issues, getting wiring out there, all of that sort of thing. So sometimes it doesn't have an emergency light, or it has an ineffective emergency light. By using a photoluminescent system, we're saying that the daylight, remember it doesn't need to be direct sunlight, but the daylight will charge that system enough so that the stairs will be visible all night. So right through the night, that will work. We use the luminance test to test the products that they are suitable. Now, there is a limit. You can say, okay, what if it was at the North Pole in the middle of winter, there was no light? Clearly, the further north or south you go, there is a limit to when there's enough daylight to charge the system all night. That's been calculated or determined to be 47 degrees north, which is just going north of Japan. So Philippines is well within it. Why do we know it's 47 degrees? Because New Zealand is down here and it's about 47 degrees. It's the southern tip of New Zealand. So systems like this can work throughout New Zealand to 47 degrees south. Same in the northern hemisphere, 47 degrees north. Once you get up here, the winter days just get too short. In New Zealand at the moment, in the winter, we would have the sun come up at 8 a.m. and be gone by 5 p.m. So it's a short period to charge and then a long night to survive that charge. So 47 degrees is
This sun will be up during the working hours.
sorry?
At least the sun is up during the working hours in New Zealand, 8 to 5.
Yes, yeah, doesn't do overtime. Okay, so that's what emergency stairs would look like. The outdoor flight of stairs, can't quite see the handrail markings that are quite obstructive, so you can't see them there. But the steps, the landing, the handrails. Okay, the next problem to overcome is what's known as the shadow effect. So, your emergency lights are either in the ceiling or in a stairwell, often in the landing, right? So it's shining from here down, and it's got to somehow cast its light down on the edge of the steps. Photoluminescent system, again, just remember it needs 54 lux on it for 60 minutes before occupancy and during occupancy. What's the shadow effect? So if you've got overhead light and you've got a crowd of people evacuating all at once, they're actually blocking the overhead emergency light from getting to the ground. So they're creating their own shadow, and it's been shown quite clearly that that really slows down egress times. So there we've illustrated it with lights in the ceiling, as it were, but equally, of course, that light that we saw are often in the landing and shining down the stairwell. Same thing though, the light can't actually get to the steps, so people just move slower. If they're photoluminescent material on the steps, again, you've got the emergency lights casting the shadow, but the edge of the step is still marked and people can easily see it, and they just move faster, a lot faster. Battery and generator reliability. So many documented incidents of generators failing, batteries failing. You know, batteries are a constant issue in terms of keeping an eye on signs that are still operating. One of the reasons this sort of photoluminescent system came about is that there was a San Francisco earthquake in the late 1980s, and the jolt of that earthquake actually meant that 80% of the generators didn't fire up. Now, you know, whether they were well maintained or not, no one really knows, but 80% of them didn't work because the shunt of an earthquake just knocked something and it didn't start. So the thing with the photoluminescent system, if you had the light on it, it is fail safe. No matter how much you hit it, try and burn it, anything, it will still operate. Sort of a related problem, changeover times for generators. I think in the fire code here it's defined as 10 seconds. So if you have an emergency lighting system, it needs to start up and change and turn on within 10 seconds of power failure. Sometimes that's challenging for older generators. So again, the photoluminescent system can bridge the gap between the power failure and the generator starting up or switching over to a centralised battery system. The VIOP system is immediately visible. There is no start-up time. Smoke suppression issues. Okay, so you've got, like, the fact is nothing is visible through thick black smoke. Once you have thick black smoke, you can't see anything but it, and it is probably the it is the key threat to human life in a fire. A figure that was taken, I think, from Australian studies going back some time is that 80% of people that died in a fire died within 10 metres of the exit. What went wrong? They couldn't see the exit. So smoke and visibility through smoke is a big problem. Older buildings don't have smoke extraction systems and have older materials, so that there's probably more smoke and getting rid of it isn't that efficient. So a system such as here helps. So, okay, so this is a typical UL 1994 system. Obviously, the word exit up here in the Philippines, and that's how it looks with the lights on. And it also has a low-level exit sign on the door. See why that is in a moment. So smoke starts filling the thing. It obscures. It doesn't actually matter what that sign is. You have thick black smoke, you're not going to see it, but it will be higher for a period of time, and that's where the low level systems come into their own. Yeah, there the electricity hasn't failed yet, but if it does fail, that's what you see. So what it's doing is putting the photoluminescent elements at a lower level, so they avoid the smoke for longer. Not a total solution, but seconds count in these sorts of situations, and this does give you extra seconds, if not minutes. around batteries, recharge times. So this is becoming more and more of a problem because of brownouts, climate change, when there's more weather events, and like the emergency illumination must be available at all times. Batteries are spec'd to last an hour and a half, they might last a bit more, but the recharge time is once they're drained, can be 16 hours or more to recharge them if they're totally drained. So how does that work? A fire can easily occur 2 or 3 hours after the brownout begins, or after electricity's been lost due to an earthquake or typhoon or a security issue. So, you know, in New Zealand we are also an earthquake zone. We had quite a big earthquake in 2011 where I live, and like I know for a fact that throughout that period, for a year or two afterwards, we had aftershocks, and quite big ones. So you'd often get a bit of a shake, and it would knock the electricity out, but if it evacuates, it comes back in because it's gone, and then you get a bigger shock later, and it can be an hour or two, can be 3 hours, can be 6 hours later. That's why the whole recharge time is really coming into being examined quite a lot. PL system, like, remember, like a maximum recharge time, if it's totally dead, might be 90 minutes. Remember we had the charge time before, 54 lux for 60 minutes? Yeah, it could be a lot faster than that, 90 minutes. But it will recharge a long time before the batteries roll. Right. So, the last thing we're going to look at is quality assurance. So, got some standards, we've got some testing products. How do we make sure that those products get installed and they're going to keep working? First of all, use a good specification for the products. Make sure the right products are in the documentation. This is a master format document, which is a US-based approach, and it has a standard document with all of the products listed and a whole lot of other specification requirements that mean they're in a Word document, so they can be copied and pasted into your specification or your procurement documents. But they have all the detail in there to specify the right level of products. And I think Keith will have, most manufacturers will have specification documents for their products. So look for specification documents. Master format is it's a very long, complex document. They may also have the rapid spec docs, which are just stripped down versions with really the products and the testing required. Make sure that the products, we see quite often that products on websites say that they meet this standard or whatever, but you ask for where's the certificate or where's the report, no one can produce it. So, actually go and ask for the reports, ask for the certificates. The likes of UL, you can actually go to the UL website, and it'll take you to all of the products and the companies that have been certified by UL. So you can simply do a search on whatever manufacturer you're dealing with Ecoglo, just plug in Ecoglo, and it will bring up all of the UL tests and certifications that are there. So, one product can be made and sent to a lab and tested, but obviously you need to know that it's not just that one product that was produced that there is a quality system that makes sure that each and every product coming off a production line meets those standards. And ISO 9000 is such a quality assurance system. Why do we need these things? This, just a few examples. This is a stairway in New York City. New York was the first city to implement photoluminescent systems after 9/11. So they looked at their whole building code after 9/11, and that's when they started putting in those UL 1994 systems. What they didn't do in the early days was have durability testing and inspection. So this this installation was actually put in by a very, very large American company listed on the New York Stock Exchange, and they put it in the stairwells. And I don't know if you've been to New York, but in a lot of ways in summer it's similar to the Philippines. It's humid and it's hot, and the tapes just wouldn't stay on the wall. They just started delaminating. This company, Brgy was the name of the company, and that really meant that they exited the market. So it was a major failure in a lot of buildings and totally destroyed their credibility. Here goes some other product. These ones are from Singapore Public Housing, HDB Housing, it's known as. Although there is aluminium or aluminum base, it's actually just a tape on a base. So you see there it's delaminated, there a coating is delaminated. It just doesn't take long for that sort of product to be, just loses visibility or loses luminance performance. Here goes some products that are not HTC. So often these are from Australia or out of China. They were made to look similar to the Ecoglo products, but like this we know in the industry, it isn't a high, it has to be cured at high temperature. It's just a liquid photoluminescent materials poured in some grooves, and it dries, and it's there. It's there for not that long. It starts delaminating, it cracks. A simple way to test, if you really want to, if you've got a product and the manufacturer says it's HTC, you get like a sharp, just be careful at the end of a knife or something like that, a screwdriver if it's a small one, and just try getting it under the edge of the photoluminescent material. If it's high temperature curing, it'll chip out like a little bit. If it's not HTC, you get it go right along and the whole lot will start peeling out. So what's the problem with those sort of products? The problem is they won't work effectively, they won't absorb the light and then re-emit it. One of the things with photoluminescent materials is that they need UV light to operate, to work. That's how a photoluminescent molecule works. If you put that in a plastic carrier, plastics don't generally like UV. So you got your light source and a well-functioning photoluminescent material. The light is going in the material through the layer of whatever it's being carried in. It's getting into the molecule, the photoluminescent molecule, and then that in due course re-emits it out. So any plastic PVC would look like that and operate like that when it's first installed. But over time, as I said, UV, plastics don't like UV, and over time that carrier starts to change colour, and it gets all milky, UV doesn't hurt the photoluminescent material, but what it does do is it just blocks the light getting in and out. So the whole performance of a plastic that's starting to discolour just dies quite a lot. This is the two approach, clear carrier, age carrier, let's say. And test for the HTC, as I said before, that HTC test proves that the product has been through a curing process and won't perform badly in adverse conditions. So that's all we had. Questions?
Sir, the temperature curing with its chipping and discoloring of the materials,
Yeah.
is the one that made the Ecoglo.
Yeah.
It's regarding the luminance.
Yes.
My
Yeah.
question is about the luminance.
Keith, they're all HTC products there?
Apart from the evacuation plan, everything is HTC.
Okay. Yes, so all of those are HTC products.
My question is about the luminance. Will it not fade in time, 5 or 10 years?
Okay. So an HTC product won't degrade in luminance. That's why the common, an HTC product, that's why they have a 30-year warranty. The fact is they don't degrade at all, but giving someone a limited warranty sort of is incredible. But there is no...
That means including the visibility threshold, it will
Yep.
get lower?
Yep. It will, and I think, Keith, you warrant it indoors for 30 years?
30 years for indoors and 15 years
Even
for
printing, including the
Yep,
printing?
yep, because the printing indoors, it's not gonna, there's not enough, real enough UV there to make the printing fade. As I said, outdoors, that's a different issue, and that's why it's more like a 15-year warranty for outdoors. But outdoor use, there'll be a clear coating over to try and protect the printing. But you're right, like the printing is the weak part, but it's not an issue when it's indoors. It's the
Based on IES, Illumination Engineering Society of North America,
Yeah.
the illumination level for exit ways or exit pathways is 50 lux. So, how long it will take to charge these directional lights if the available lux on that area is only 15?
Oh, I see. So, but then you're talking about the emergency lights need to perform to 15 lux,
Yeah.
correct?
Yeah.
Okay, so what,
So my question is how long it will take?
yeah.
Charge this-
15 lux, it would take too long. It's not viable, but remember, that's why any of these signs, like, need enough light on them for 60 minutes prior to occupancy. So that's 54 lux
Yeah.
is what's required
Yes.
on the face of the sign for 60 minutes. So 15 lux, it might
3 hours?
it might charge it eventually, but it's not really viable. But then again, that's the emergency light, and you won't have the emergency lights on charging it anyway. You have your main light. Understand what I mean? Like the 15 is in an emergency, so it means the electricity mains have failed, and it requires 15 lux of emergency lighting. When the power hasn't failed,
example, this one, how many lux photo effects? 30?
Here, if light measure, okay?
I don't have it.
I'd say couple of
It's okay,
hundred.
I'm just asking.
Yeah, couple of hundred, maybe 100. In the shadow, yeah, but far more than 15.
Yes, thank you. My question would be precisely like with Ecoglo Philippines. It is nice that you're, in your presentation, you have shown other companies with substandard products, right? It is very important that the product is very reliable during, especially during fire, because lives are at stake. So, the question with Ecoglo is, what would make you stand out against competition? Because I believe there are other companies who are also manufacturing products like this.
If you're talking about HTC products, there's
From Ecoglo Philippines.
yes, there's nobody else here that manufactures with such a manufacturing process. As you all would know, the market here is predominantly controlled by PVC signs. What you all see are basically PVC-based signs, or printers that use a very luminous ink, or printers that use a very luminous ink and print on a substrate that is not a photoluminescent substrate. For example, if you look at all the malls, just like a uniform, just like our uniform, see, it's a very luminous ink, so it looks like it's illuminated. Just like what I think Trevor presented this as well, it's the same comparison with reflective signs. It looks like it's luminous in the day, but it can only look luminous in the day when there's light. Same thing, it doesn't serve a safety purpose in an emergency, because when there's no light, there's no illumination, just like a uniform like that, right? And because the evacuation plan market is so big, so any printing shop basically can do an evacuation plan, or they can do a sign, but they give end users the wrong information. Just like why you see signs are so common on Sintra board. When the printers will say that they can use photoluminescent ink and print on the sticker and stick on the Sintra board. But that's not possible. The same thing with the PVC signs. It's not possible because BFP requires the backdrop of the evacuation plan to be on a photoluminescent material, irregardless of whether it's PVC or metal. Yes, they don't dictate, not like the signs, they don't dictate the lumens level and for how long it needs to be illuminated. But basically to them, it needs to be on a photoluminescent background. So if you use PVC, if you use PVC, it's fine, but it needs to be a PVC photoluminescent sheet. You cannot just use a PVC base or a Sintra board base. So to answer your question, with this kind of manufacturing process, there is no competitor here, not even in Asia. Not even in Asia, right?
So if I order from Shopee,
It's just like we have this order for this import company that is comparing our products to products on Lazada, right? And the price of our products is the same price as the PVC signs on Lazada. But this is our problem. Like example, Joseph, where are you? Okay, Joseph is from PSMB FI. He's one of our first 10, his company is one of our first 10 customers. I think in 2022, right?
Yeah, 2018.
2019, let me see, you are like the first 3 customers when we first set up, right? He will explain to you all that it's very hard for us to present or to sell this product to anybody if you do not have a product presentation. Because you don't understand, if the person doesn't understand how the technology works, it's very hard. And there's only one thing to do, is to switch off the light, and like what Trevor said, show you that the HTC manufactured product doesn't have a 10-second, what do you call it, transition period to go to any form of emergency lighting. Right? So that's the only thing. And if you don't see this kind of thing, the end user will never understand. You know, they will never understand. So yeah, that's my. If you want to compare apple to apple, like we always tell our customers, when we do bidding, because we mainly sell products through bidding only. If you want to use our products, then it must be specified based on the high temperature curing manufacturing process and the warranty which nobody can give. And even price wise now, we are not far from PVC signs. Actually, some PVC signs are even more expensive than us. I know looking at this, you all will think the signs are very expensive. But actually it's not. I can tell you an exit sign only costs 370 pesos with a 30-year warranty. Yeah. Without international standard. That means all the signs are manufactured the same way. The same manufacturing process. It's just which goes to UL for certification, which goes to whatever other standard. But the one that we made for BFP is only 370 pesos. So technically, one sign, the sign costs only 10 pesos plus a year. And the building will definitely be reconstructed before the warranty finishes. That's a fact. That's for sure. Of course.
What
Yeah.
about your stay here in the Philippines?
My stay here?
Yes. How can we assure the warranty?
Or the product,
Product.
he means the product.
The company.
Product warranty.
It's the company. The product warranty, I'll give you an example. Even if the Philippine office closed, the product warranty comes from Ecoglo International in New Zealand. So it doesn't make a difference.
Yeah.
Yes. So are these manufactured here in the Philippines?
No, it's manufactured in New Zealand. But we keep stock here.
So can we turn off the lights now?
It's hard, but I will try. No, because there's light from outside.
Yeah, yeah. Should be there.
I don't even know how to off this light.
Yes.
How to off it? Can you close something?
So it's not made in China. It's not made in China. It's from
No.
Okay. I will find a way to switch off the light. But there is light here in the room.
Yeah.
You see, if we charge it outside,
Mm.
and it's raining now. It's raining heavily now.
Mm.
There's no sun outside. It's raining heavily.
okay.
This is how it is. You can ask Joseph. If not, you can ask Jane. Are you from De La Salle? Okay. You can also, well, I have two people here that are our customers. One is PSME, FI, and De La Salle, but she's not from. So you see, it's very hard. This is the problem. When the light
Yeah.
is stronger than the illumination, you don't see it,
Yeah.
right? Because it's charging, but you can see a slight difference.
It's already glowing.
Yeah.
Okay, never mind, I'll do one more thing.
If you look at the key tag, the site on the seat, take that home with you and just leave it in the daylight, tag, and then just put it beside your bed when you go to bed. And you'll then see just how long it lasts and how bright it is. So let it sit, just leave it beside the bed in the daylight during the day, and yeah, it will glow at night. Don't call me complaining that it's keeping you awake. But
This is a big help.
You see, just like this, because he used his torch and charged the thing. So this is the proper way in which if anybody ever proposes or presents a photoluminescent product to you, it should be able to do this. Same thing with LED light, because I can't get it out because there's just too much sunlight from the outside.
Yeah.
It should
Yeah.
be able to do this, and so when it's fully charged, it's like that, right? It's like that.
you know, it's one of the small jars.
How long will it last?
Yeah.
It would last the whole night, but of course, after like 3-4 hours,
It will fade.
Yeah, it will fade, but you still can see it.
Well, you managed to get out.
Yeah.
Yeah. Our ratings only maximum 2 hours.
You want to stay
More than
There's no use for it to be able to last the whole night because the whole building would have burned down.
Sa namin
So,
si
doesn't
sa
really-
Dennis yung sir.
Denny.
So it doesn't really make much of a
Sa akin, sa office din.
Is there any other questions you all would like to ask me, or do you all want to go for a break? And then we can always speak, or if you want to find out more about the product, you can always.
How long has the company been for that?
I will email it to you all after the meeting.
Philippines,
Yes.
2019.
Kailangan niya naman
Kasi ikaw yung sila din.
1996.
I think I can invite you to present your product in BOMA.
At this product,
Are you familiar with BOMA?
can you give us a
Yeah.
sample where it was installed?
Building owners in
Which
Manila.
So we've
building?
been trying to find.
How about this hotel?
Which prestige building you have installed
I
it
can
in the
give you
Philippines?
the number of the.
Government or private?
Yeah.
You can contact her.
Regardless whether it's
So
government
she can
or
schedule
private.
you for the
Yeah, okay.
presentation.
Uh,
We work a lot with BOMA and the USA.
Philippine Sports, okay, I start from government first. Philippine Sports Commission, GSIS, Philippine Port, Cebu Port Authority, okay, then we go to Rail and Metro, LRT1 Cavite Extension, schools, De La Salle, Laguna Campus, UST,
Ito mag-date mo ng pangalan sa bukid. Sarado ng phone.
private malls, Ortigas
Si Ma'am Pedro.
in the new Green Hills Mall. What other malls?
Sir, if you are not the one who installed fire exits in this hotel, then who installed those signs in this hotel? That is the interpretation here, right?
No.
We were
Well,
overjoining the convention days.
with hotels, for example.
This hotel,
Yeah.
this particular hotel.
Yes.
Did you install
At the
those
same time,
signs?
No.
So
It will be in the
whoever installs is a competition with Ecoglo. That is my question.
Yeah.
So
But it's totally missing. I think most of the
No, none of the signs are for the best in that area.
okay. So that's the difference.
That's the difference. That's the difference. That's the difference. You see, there are millions of companies here in the Philippines.
Yes.
There's no way for us to supply to everybody,
Yeah.
right? So, of course, we select based on our marketing approach as well, because we mainly specialize in bidding projects, as in the company. We have resellers, then the resellers can sell it to whoever it is. I don't sell to private for particular reasons, because we try to maintain cost effectiveness for the product.
Yeah.
It's no use for me to sell to one engineer, the engineer sells to another engineer, the engineer sells to another architect, then the price becomes 60% more, so it's useless. Then it spoils our name as well.
Yeah.
So that's why we prefer to do it ourselves. You can ask Joseph,
Ayun tayo, ayun
you can ask her, although she's not from the Laguna campus, but it's the same thing. That is the reason why we don't, even like them, for example, spoken to them, right? That's the reason why we all don't want to do that additional markup, because then the product doesn't become cost effective anymore. That's the whole thing. Yes, sir.
Yeah, just you
Ah, yeah.
share that we are an accredited safety training organization in the Philippines, accredited by DOLE. And as a safety training organization, we don't actually refer suppliers, especially on training. But our company, of course, during our training, some of our clients or companies will ask us, for example, fire extinguishers, PPE, etc. We don't really refer. But of course, there's an opportunity. It's not our business is training. But when they ask us as a value-adding services, is to refer them to somebody, okay? But we make sure that that particular company is credible, have quality, and our company only refer one PPE, one fire extinguisher supplier, and of course, if somebody will ask us about evacuation plan, we always refer Ecoglo. We try to study that because at the end of the day, our company will also be impacted if we refer somebody who has a substandard. Like for example, we have a problem in the Philippines, especially in fire extinguishers. You all know that the issue right now. We have a fire code in the Philippines. What's the minimum rating in the fire extinguisher? What's the minimum numerical rating based on the RA9514? If you're aware, the requirement is 2A 5BC. But here's the problem. Suppliers still supplies fire extinguishers with substandard numerical rating. You can see 1A 1BC, 1A 2BC. But the main requirement, the minimum based on NFPA in the US is 2A 5BC. And that is what is written in our Fire Code of the Philippines. And that's the problem. They are supposedly the expert. And here we have expert talking about photoluminescence. And they can prove it. So what we expect to suppliers that if they're expert at a particular product, they should actually help us. But you ask a fire extinguisher supplier, they will sell their substandard products to us. So with this, I fully guarantee the quality, the integrity of Ecoglo. No, I'm not. I'm signer cost management. Signer cost. And our clients here is from Skyway. They can also understand. I know LaSalle got Ecoglo because it's green. Okay. I don't know if you can get Ateneo.
Thank you, Keith, is providing refreshments out in the lounge area, so please feel free to stay and have a drink and ask questions, and we'll be available there to your time.
And then your is that what again the this one, But you're correct. I will put that there. So yeah, but so you might be confused that no, it's not the emergency light that here we are renting out the emergency light there. Yeah. So but you're correct. It chooses to put that everywhere. And you don't need to put them in locations.
So if they want coffee, tea, water, they can get from here and then go over there. Is Ronald Dudley still there? Tough. Is Ronald, Sir Ronald still in? Get some coffee and all that. Then we can move to the
Sa Manila po. Yes, sa may Pitupus. Ang director po kasi ng safety namin yan, si Director Colin Pang.
Ang full po namin is 3 pero ano pa rin po mga fancy.
Sir, mag-away po tayo, sir.
Dito, ang more dito ko. Akala ko lang. Doon ako working. Abi, teka, hindi kami umiinom eh.
May company na rin tayo, sir.
Grabe na talaga yun.
Ito sa Manila. Office namin mag-out na kami. Ilaw. At smaller na indoors outdoor namin yung mga
Sa school kasi yung mga binibili namin na sabi nila.
mostly outdoors. Pero these are mostly
So, kaya rin talaga po.
kasi nakita niyo yung talaga mga handrail,
Feeling kami.
handrail, tapos yung sa
Ito, ano pa lang po yun?
parking,
Hindi pa lang po
ito naman po
kaliwa.
yung sa mga stairs.
About natutupan siya.
May iba pong ang gusto lang nila yung ganito. Kaya may ganyan mga pero most po talaga may talaga makita. Yan po yung kaninang ilaw pag sinatouch niya.
May meron din ang ilaw. Hindi ano?
Hindi kasi siya mabilis yung pag-uwi.
May meron siya ng ilaw.
Pwede po commercial light, pwede po, pero hindi siya ganun kabilis mag-charge. Unlike pag yung direct light ng sun or UV light. UV light po talaga
There
direct
is
siya
some light talaga.
Exterior. Outside na.
external, ito po mostly indoors po yan kasi sa mga exits natin. Pero yung outdoors natin, yun yung mga disaster preparedness namin, may nakalagay na tsunami prone area, yung po yung mga outdoors namin. Ayan, may mga ganyan din po, may gumawa din na kami.
Kaya yung gano'n. Gagawin dyan, may plano pa yun.
Bibigyan kayo sa ilalim.
Kaya yung gumagawa.
Bigyan po kami ng plano kasi hindi siya kasama
Kaya
sa
ang gagawa.
Sige, print lang.
i-print lang po. Tapos
Kasi kayo nakakalam na marka ng building.
ano po, yung ano na talaga, print ang wala na rin. Tapos tsaka siya i-print sa
I-edit mo pa ba para
Meron naman sa yung pinipil ng presyo.
identify lang
Nag-aaral din kami ng idea to, ano po, mag-build kami ng online presentation para mas marami kami ma-reach. Kasi pag yun yung fiscal, di ba, kailangan pumunta sa Manila na location. Pero so far po, yung, eto po, pangatlong ano na to, pangatlong batch ng PLC seminar. So far naman po, lagi yung
Dito plastic.
yes.
Kaya nga pala. Oo, kasi di ba? UV does not like plastic.
Ayun po, correct. Yung wait lang po, ito yung sa handrail. Kasi yan po yung sinasabayan niyo yung kawakan. Tapos, most of the time, ito yung ginagamit na perimeter dun sa perimeter, diba, sa landing. Ito are
Ako sa mga steps. Sa mga steps.
Sa steps naman,
Sa riser.
depende po. Meron po siya kumukuha ng insert lang sa mga anti-slip. Kaya may kasama. Pwede po kumukuha kayo.
Yan pala yung alam ko yung mga direction sa
Inside office.
Hindi pa lang yun naman po. Yung nasa maliit na part ng gano'n nakalagay.
Ito size na file. Meron ba kayo sa size ng file sa liba para sa yung file na ikakabit na meron ba?
Ganito po sa
Susunod po yung rule
Thank you so much po. Ano lang po, nabigyan mo sila ng
Meron na.
Isa.
yun, sa QR. Yes po. Ito, sorry. Ito po yung sample na po. Ito naman po yung
Kailangan subukan ko kasi at least 15 years.
Wala po, wala po pala. Kasama din yung
ang outdoor po ang 50 years. Pero so far, wala pa naman kami sa third year. So far, wala
Kasi
naman po.
maya-maya,
Hindi talaga naman nakakabalik siya.
halimbawa, umalis kayo.
Sabi nga po, sir,
Ibang company.
technically, wala siyang entirely, parang nagbigay lang ng definite na numbers for the wallet purpose.
Saan ang store nyo?
Sa Binangon ng design po.
Bali online din, awan o. Transaction.